What is a metric when building TensorFlow models? Imagine you're trying to see how well your machine learning model is doing, but not just in training. You want a clear way to measure its success across different tasks. That's where metrics come in. When you build models with TensorFlow, a popular machine learning framework, metrics help you understand how your model performs. They are functions that give you numbers indicating how accurate or reliable your predictions are. And like loss functions, which guide the training process by telling the model how far off its predictions are, metrics are more about measuring the quality of those predictions. You can think of loss functions as the coach giving instructions during training, while metrics are like report cards showing how well the model is doing. If you're working on a classification problem, where the model predicts categories like yes or no, metrics such as accuracy are common. Accuracy tells you what fraction of predictions are correct. Precision measures how many of the predicted positives are actually true positives, which is useful when false positives matter. Recall shows how many actual positives the model correctly identified. The F1 score combines precision and recall into one number, balancing both. For regression tasks, where the model predicts continuous numbers like prices or temperatures, metrics like mean squared error and mean absolute error are used. Mean squared error calculates the average of the squared differences between predicted and actual values, penalizing larger errors more. Mean absolute error finds the average of the absolute differences, giving a straightforward measure of how far off the predictions are on average. In TensorFlow, especially when using the Keras API, you can specify these metrics when you compile your model. For example, you might choose to track accuracy or mean squared error during training. These metrics are then calculated after each epoch, giving you real-time feedback on how your model is improving. Using metrics is also helpful when comparing different models or tuning parameters. They help you decide which model performs best on your data. Plus, in ethical AI development, metrics can help ensure your model is fair and reliable before deploying it. You might use metrics to monitor training progress, evaluate your model on test data, or analyze performance across different groups of data. Some tools even let you visualize these metrics over time, making it easier to spot issues or biases. Choosing the right metrics depends on your task. For classification, accuracy, precision, recall, and F1 score are common. For regression, mean squared error and mean absolute error are typical. Remember, metrics give you a clear picture of how well your model is doing and help guide improvements. Whether you're working with ChatGPT, DALL-E, or other AI tools, understanding metrics ensures your models meet quality standards and perform ethically.